Today we're going to talk about arithmetic sequences. Yesterday we said sequences were any ordered list of numbers. They followed a pattern, and an arithmetic sequence follows a specific pattern. It is the sequence in which the difference between consecutive terms is constant, meaning that between each number the difference is the same. You subtract them, you get the same amount. That means we're going up or down by the same amount each time. We're adding 5 each time, or we're subtracting 6 each time. It can be a fraction. I can go up by 2/3 each time. I might go down by 1/2 each time. These would all be examples of an arithmetic sequence. The difference itself is called the common difference. So that amount that we're going up by each time, or that amount that we're going down by each time, is called the common difference. Let's look at some examples. Identify which of the following are arithmetic sequences and find their common difference. So here we have 3 examples. Identify which of the following are an arithmetic sequence. So in example A, we've got 2, 4, 8, 16. We want to know, is this an arithmetic sequence? Are they going up by the same amount each time? Well, here we went up by 2. But here we went up by 4, and here we went up by 8. So no, this one is not an arithmetic sequence. Now there's a pattern. Notice it's doubling each time. 2 times 2 is 4, times 2 is 8, times 2 is 16. There's a pattern. It is a sequence, but it is not an arithmetic sequence. Let's look at B. 6, 12, 18. So let's find out what the difference is here. This one went up by 6. This one went up by 6. That's the same number, so yes. This one is, in fact, an arithmetic sequence. Now we need to find its common difference. They wanted us to find the common difference. What was it going up by? It was going up, so that would be positive, by 6. So its common difference must be 6. C, we've got 1/2, 1, 3/2, 2, 5/2. All right, so we've definitely got some fractions going on here. This one went up by 1/2. If I subtract these two, this one went up by 1/2. Subtract these two, oh, that went up by 1/2, and this went up by 1/2. So, yep, they're all the same. So, yes, this one is arithmetic, and in fact, the common difference is again positive because it was going up. Now, if it had been going down, that would still be arithmetic. We would just make the common difference negative. All right, so all sequences we learned yesterday we can do formulas for, recursive formulas and explicit formulas. The cool thing about knowing that a sequence is arithmetic is that all arithmetic sequences have the same formula. They have the same recursive formula and the same explicit formula. We just have to plug some numbers into it. The recursive formula for all arithmetic sequences is the next term is always equal to the previous term plus the common difference. We're adding the same thing every time. D is the common difference. If we look at our example B from before, it says 6, 12, 8. We determined that yes, it was arithmetic, and the common difference, D, was equal to 6. So if I was going to write the recursive formula, it would be that the next term is equal to the previous term plus D. Now, we need a term to start with. Generally, you always want to use the first term. Okay? It's going to be the next term is equal to the previous term plus D. But we need some term to plug in there. All right? So any previous term, n minus 1 plus 6. But if we were going to continue this pattern on, this is the formula, and it'll always be the previous term plus 6. It'll always be a n minus 1. But if we're going to have to start this thing and actually find out what everything is, we do have to have something to start with. If we wanted to continue this pattern on, we would start with 18 and then just keep adding to find the next term. But the recursive formula would be the next term is equal to the previous term plus 6. So that would be its recursive formula. The explicit formula. The next term is always equal to the first term. Don't forget, A1 does mean the first term is equal to whichever term we're looking for, n, minus 1 times the common difference. D is still the common difference. So let's look at that same example again. We got 6, 12, and 18, so we know that our D is equal to 6. We also know that our first term was also equal to 6. So let's plug it into our formula here. The next term is equal to the first term. Okay, this is the first term, 6, plus n minus 1 times d. In this problem, d was also equal to 6. Now, we can't leave it that way. We have got to simplify it. You can't just leave it hanging out that way. We're going to have to simplify this. So don't forget to distribute your 6. We're going to get 6n minus 6. And we've got our 6 over here. So the next term is going to be equal to 6 plus 6n minus 6. So 6 minus 6 is just going to cancel out. So I end up with the next term, a sub n, is equal to 6n. So now that we have that explicit formula, we could find any term in this sequence. We could find the 100th term, the 20th term. Plug it in, we would know what that term was. So these were the two formulas for arithmetic sequences. Something else that we need to know, the arithmetic mean. Arithmetic mean is the average of two numbers. We've been doing the arithmetic mean forever. We've just always called it an average. Don't forget that an average means that you just find the sum of the two numbers, and then you divide that sum by 2. So the arithmetic mean of two numbers is the average of those two numbers. Now, how does that help us with arithmetic sequences? For any 3 consecutive terms in an arithmetic sequence, the middle term is the arithmetic mean of the other 2. So, in any arithmetic sequence, if you know that something is an arithmetic sequence, then you can find a term between two terms just by doing its arithmetic mean. So, for example, find the missing term in this arithmetic sequence. 15 blank 29. So, if I wanted to find that missing term, I would have to find the arithmetic mean of these two numbers. So, 29 plus 15 is equal to 34. 34 divided by 2 is 17. So the missing term must be 17. And so that's how we use the arithmetic mean to help us find missing terms in an arithmetic sequence.